So you've just bought a 3D printer and you already want to throw it out the window. Fear not, let's make this fun. My name is Bren Maartens from Netram Technologies, and ZEN Filament has asked me to lay it down when it comes to 3D printing.
Alright, cool guys, so we're in Cura. I've set up my Creality in the 3D printer by just the default setup. By default, they'll all come with a 0.4mm nozzle. That's great. On this tab here, we can see where we'll start the slicing process. So what we'll do here now is we have to first add the first model to know what we're doing in here. So I've already put a file in here before this video. So here's a cube that I had in the last video. I think in the previous video it was 30 mils by 30 mils. We could scale it, rotate, and move it on this left-hand panel here. So let's click standard quality. So in this section here, we will start to talk about all the different, crazy tabs that are here. By default, it'll be on basic selection. So this is what you'll see when you first install Cura. First thing we'll look at is quality. There's a lot more settings than this if you click this fancy button here, and we will get to that later. But right now, we're just going to stick with the basic settings because we just want to get up and going. So quality. This is your layer height, and that is the resolution, the basic resolution of your model. You get 0.12, you get 0.16, 0.2, 0.3 or 0.28. 0.2 is your standard quality. In fact, Cura comes with a few presets. You can see standard quality, it says there, and you can change from super quality, dynamic, low quality. If you want something to do really quickly and you don't really care about the quality, you can use low quality. It'll have less fine resolution. But for me, I always love 0.2. It's a good medium between really good and kind of bad quality. So 0.2 is a great layer height to start with. Walls. So your wall thickness is always going to be how many perimeters each print has. So a wall thickness is always a multiplier of your nozzle. So wall thickness is always a multiplier of your nozzle. And the way this works is that if I have a wall thickness of 0.8, you would imagine that 0.4mm nozzle would give me 2 walls. And it will do that calculation for you. For example, if I wanted 3 walls, I can make my wall thickness 1.2 millimeters and automatically puts the wall count as 3. Because you can imagine that a printer can only extrude out a thickness diameter as big as the nozzle would be, right? So that's exactly how that works. So right, cool, but 0.8 is a really good place to be. So 0.8 at 2 walls is perfectly fine. Your next will be your top and bottom layers, and this is the top. It's pretty self-explanatory, to be honest. It's top and your bottom layer. Why you would want a thick top layer is because if it's too thin, then you will see the infill through the bottom. It'll just one or two layers. It might not be thick enough. Bottom thickness also same thing, but remember you don't want too many layers. Too many layers might take a while. So if you have a large surface area part, you can imagine that it going up and down like that so many times, it will just take a long time. So again, your top and bottom thickness is a multiplier of your layer height. So if our layer height is 0.2, you can imagine that the top thickness and bottom thickness, would equate to how many layers that would be. So for example, if we're going to go with 4 here, if we're going to go with a top thickness of 0.8, that would equate to 4 layers. So 2, 4, 6, 8. I mean, it makes perfect sense. So if I want 1 mil, you can imagine it's going to be 5 top layers and so on and so forth. So just reset that back to default, reset. So the 4 top layers and 4 bottom layers is more than enough for most prints. Your infill, again, your infill is now how much of the model is infilled with plastic. And this is a calculation that Cura will actually do for you. So if you say, hey, this cube is really cool, I want this thing to be 20% filled with plastic, and you can select your infill pattern, and you can play around with all these different types. Some of them are more beneficial than others. For this particular video and this model, a cubic pattern is perfectly fine, and I'm going to show you an example of this right now. I say slice, and then I go to the prepare mark, and you can see there's our model. Let's close this tab here, and if we cycle through each layer, you'll see there's all your infill there. This is a pretty self-explanatory way of doing things. So that's how that works, and you can see that if I go back to prepare and I change this to 80%, say slice, and you'll see how this changes. You'll see how this changes the time as well. 2 hours, almost double than what the previous one did. So if we go back to preview, you can see the infill pattern is really, really dense. Like that's really nuts actually. It's almost solid at that point. So not recommended. Usually around 10 to 20% is a really good mark for infill. So I'm going to leave that at 15%. Let's just slice that so we can get that out the way. All right, go back to prepare. Next thing we have is material, and this is where we'll set our temperatures. There are a lot more settings in this category as well that I'm not going to get to in this video, but printing temperature is very important for 3D printing. Depending on the brand of filament you use, it will range between, especially for PLA, it'll range between 200 and 225. Obviously with ZEN PLA Ultra, perfect temperature is 220 for us. This is actually a print done with their Sunset Swirl. It's a gradient filament that they're bringing out now. It'll fade between colors, which is super cool. And this is done at 220. The build plate temperature is 60 to 65. Should be fine as well. Make sure you're using the right temperature range for your branded filament. That's really important. So your speed, by default, most Creality machines or most Cartesian-based machines will be at around 50, 55, and 60 millimeters per second by stock. You can tune it to be a little bit faster depending on what firmware is on there. For example, the Delta machines, I've seen guys print some insane things at insane speed. So I think I saw a machine that did 150 millimeters per second. Like it's actually scary to watch. But yeah, depending on the machine you have, you can tweak this and go up and down. You will sacrifice quality for speed because when things are moving quickly like that, inertia comes into play and you'll start to get a lot of ringing and vibration, and your print quality will sacrifice a little bit, but it's kind of a risk you have to take there, the speed. Next is travel. So travel, when we talk about travel, we're talking about retraction, we're talking about stringing mainly. This is what that does. So, well, there's actually a lot of settings here, but I'm going to talk about stringing mainly here for retraction. If you're experiencing a lot of, where's an example? I don't really have one. So if you have a lot of stringing in a print, whereby you have 2 points in the print and a gap in the middle. If it starts to print there and then it moves over to the next side over here, the gap between you'll have these strings and these lines that happen. That's all based on the filament still remaining after it started to move, and it'll basically pull it along, just very similar to how a glue gun, if you use a glue gun and then you move the glue gun after, just see that string across your desk. So very similar concept. How we get around that is we do something that's known as retraction, and that is where the extruder motor over here, a little print on it, this will move backwards very quickly just before it starts to travel, which will suck the filament back up the nozzle, trying to make a bit of a vacuum and cut that filament, that excess filament off before it moves. As it gets back to the location, or as it gets to the location where it's supposed to be, the extruder will then extrude just enough to meet it back at the nozzle again and carry on extruding at the right point. There are 2 main settings when it comes to retraction. It's retraction speed or retraction distance. If you want to find those settings, you can actually just click the settings button here. You'll see this list of just insane amount of options Cura's implemented these days, and you can type in retraction speed. We'll see a retraction speed. We can expose it there. We can also enable retraction distance and retraction distance. There it is. And now they're exposed as well. So by default, they're 5 and 45. You can play around with these if you are experiencing any retraction issues at all. Next, we have Z-hop when retracted. So this also helps a lot. What this will do is, if you're printing, your filament will jump. When you're printing, your hot end will actually jump up and retract at the same time, and then it will move and come back down again and then re-extrude. So it jumps up before it moves instead of just moving across. That jump up sometimes is enough to actually sever that excess filament that's there. So when it starts printing again, you've got no more stringing. Just be careful though, retraction speed too high and retraction distance too high will cause under extrusion. If you get to that point, you know it's a little bit too much and we need to back off a bit there. So that's all perfectly fine. I'm going to enable that. That's great. And then we have cooling. So cooling is your part cooling is from your left hand, is the fan that comes from the left to the right of your extruder. That will basically cool the part 24/7 and all when it needs to. With PLA, the faster you can cool the layer, the faster you can put the next layer on it. That's pretty much the rule of thumb for PLA. Supports. So if you're not familiar with what support is, not all models can be printed just as is. For example, this dragon here, luckily this dragon never used support, but what this will do is that if you have support placement placed everywhere, Cura will try to look for any overhang greater than 50 degrees. I think by default it's 45 degrees. Greater than 45 degrees, and it will try and build a scaffolding from the model underneath it to the point where it needs support. If we had to put placement just touching the build platform, it will ignore anything that's from the model up to the model, and will only use from the actual build platform up to the model. So if you can picture this nose kind of extending out further out there, this would need support, and therefore it'll build it from the build platform up to the nozzle, up to the part, and this will help reduce the amount of plastic you need. But yeah, if you can try and get away with no supports on any print, number one. This, for example, the angle on this print is just enough for us to not need any support, which is really, really cool. Next thing is we did support already. Last thing is build plate adhesion. So these are different methods you can use to keep the part to the bed whilst printing. Skirt. This blows my mind. Skirt, I don't know, man. It creates the skirt around the print, and it does absolutely nothing. It is the dumbest setting I've ever seen by default on Cura. I don't know, man. I've been doing this for ages, and I've never used skirts. Brim makes way more sense to me. Brim I always use, and it creates a skirt basically, but the skirt will then actually touch the model, increasing the surface area of it on the bed. This is a really, really good use for a bed adhesion tool. Brim is pretty much what the number one thing to use. Raft, I hate. Everyone knows that. Rafts are basically a small model that gets printed underneath the print, which allows the print to be started on, so it doesn't print directly on the build platform. The problem with this is that it takes a long time. It takes a lot of filament, and it also ruins the look and feel of the part underneath. If you were going for a really smooth finish on the bottom, you're gonna have this rough part that you've got to remove. Sometimes it doesn't come off. It's a nightmare. If you can help it, please don't use raft. And we don't have a dual extruder on this particular machine, so there's nothing there. So after we've done with that, we are prepared. We can just say slice, and that is it. So we have our model there. This will take 1 hour and 7 minutes. We can click preview, and there it is. There is our model. After we're done happy with that, we just click save to disk, and we'll save that to our SD card, put our SD card in our machine, and we're ready to go. That's pretty much all there is to basic slicing. There is another video after this that teaches you a little bit more about bed adhesion. If you haven't already watched that already, I'll go through kind of the basics on bed leveling. So check that out if you haven't already. Make sure you like and subscribe to any of these videos if you find it helpful. ZEN is producing a few more videos that will help with the beginning of 3D printing. That's all from me, and I'll see you next time.